6 and 11 pi over 6. See how handy this method is? There it is, used right away, very first one. Okay, so then once you have that, then this parenthesis here is equal to, has to be, in order to get that ratio, it has to be equal to pi over 6. And it could also be 11 pi over 6. So what we're essentially doing is we're replacing this box with something, an arc length, that gives me square root of 3 over 2. Well, we know if this were just a plain old pi over 6, we'd be done. Cosine of pi over 6. But what's happened is that this thing here has to be equal to pi over 6. This thing here has to be equal to 7 pi over 4. So do you see how it's just an algebra problem from here on out? Now we're going to have x is equal to pi over 6 minus 7 pi over 4. And then here it's going to be x is equal to 11 pi over 6 minus 7 pi over 4. Now it's no big deal, but you just go ahead and put in a 2 and a 3. Now what are the denominators? 12, so that's good. 2 pi minus 21 is going to be 2 pi minus 21 pi over 12 is going to be negative 19 pi over 12. There's one of your solutions. And then the other one, 2, 2, 3, 3. Now you're going to have 22 pi minus 21 pi over 12, which is 1 pi over 12. So those are your two answers for solving that. Now, a lot of people would look at those and they'd run for the hills, but if you think about covering it up, it seems easy now, doesn't it? Yeah. Any other ones that you want to see on this set? Any of these? I'm going to do one here. Let's do 6. Oh, yeah. 24. Sure. 24 fits really well with what we're going to be doing today. But before we do that, let me look at 16 real quick. What would be the best thing to start with number 16? Do you like secant squared? Do you like secant? No. What could we do to make it easier? Turn it into what? Secant is 1 over cosine squared. Yeah. And that's essentially what we're going to do with 24, is we're going to don't like cosine 2x. We're going to change it into something we do like. All right, so that's equal to 4/3. So cosine squared is equal to what? 3/4. Now, if you took the square root of both sides, you'd get cosine x equal plus or minus square root of 3 over 2. And now you're going to get all of these answers. You're going to get these two, and you're going to get these two out here. So this will have 4 answers, actually. It'll be pi over 6. It'll be 5 pi over 6. It'll be 7 pi over 6. And 11 pi over 6. You got all 4 of those answers. I'm going to make them into smiley faces or stars. There you go. Those are your 4 answers. Okay, so let's go to 24. 24 says cosine 2x equals. So what do you see as far as a function to the first power? Forget about cosine 2x. You see a cosine here. That means when we change cosine 2x into cosine squared minus sine squared, which don't you want? Cosine squared or sine squared? Which one don't you want? Because I see a cosine here. I really don't want a what? I don't want a sine squared. So I'm going to change that sine squared into 1 minus cosine squared. Is that legal in Minnesota? Oh, yeah. It's okay. So if you simplify this, you're going to have cosine squared x minus 1. And then you're going to have minus a negative cosine squared. We're going to have 2 of the cosine squareds. I'm going to add the 5 cosine x to this side, and I'm going to subtract 2. Did I do too much? Is that all right? Could have done an extra step there. Cosine squared x, there's 2 of them, minus 1 equals 2 minus 5 cosine. You add that, you subtract the 2, you add the 5 cosine, and so this becomes something you should recognize. What do you recognize? Yeah, it's a quadratic, our greatest nightmare. We can actually factor that into a quadratic. Did you see that coming, Maddie? No. So this is 2 cosine x, cosine x. Now we have to figure out where to put the 3. So we need a 5 here. 3 could go here or here, but if we put a 3 here, we're going to get maybe a minus 3, minus 2. That won't work because we need this to be minus. So one of them needs to be plus and one of them needs to be minus. So do we get 6 cosine minus cosine giving me 5? Does that work? Yeah. Once you get to this point, you're half done. Sounds terrible, but it is. Would you write 2 cases? Okay, this is important. If x times x minus 3 equals 0, what could x be to make this 0? Well, if it were 0, it would work, wouldn't it? How about x equal to 3? Would that work? Yeah, because there's a property that says if you have 0 times anything, what's it equal to? 0. What if you have negative 8.8 times 0? Will that be true? Yeah. As long as one of them is 0, the whole thing's 0. So that's why we would say 2 cases. You either have x equals 0, and then this would be negative 3. 0 times negative 3 is 0. Or if x is 3, 3 times 0 is also 0. So that's what I mean by 2 cases. And so now we're going to write it. 2 cosine x minus 1 equals 0, and cosine x plus 3 equals 0. Like I said, half done. Now, one of these is going to make us very happy, and it's the second one. Cosine x equals negative 3. When is the cosine equal to negative 3? Does it ever get down to negative 3? Never. So we would say no solutions. No solutions for this one. But for this one, we have 2 cosine x equal to 1 cosine x equal to 1/2. Now do our little magic trick that we learned a few moments ago that I said you're going to use a lot. Lifesaver. Cosine x is 1/2. So cosine is 1/2, like that. Okay. So what are the 2 arc lengths that are going to work for this? X equal to what? Pi over 6 or pi over 3? 3. And what's the other one? Something pi over 3. 5 pi over 3. Yep. And if you're looking for just those between 0 and 2 pi, you got it. If you're looking for all the possible ones, you slap on a plus 2 pi k, where k is the element of the integers. Ta-da! And that's it. The flow of these are you got to get them down to a quadratic. Then you solve it, then you get the two cases, and then you work each one of them. If any time your cosine is bigger than 1 or less than -1, you're going to have no solutions. And we welcome those because it's a lot less work. And then this one is just draw that little circle and get those two answers. Were there any others in that problem set? You picked the toughest one. Maddie, that's good. All right, so that's it.